discharge given to you, width of channel given to you, normal water depths given to you, and it says that the water going through a river or channel, it says channel, and it encounters a dam. It asks find the depths directly above the dam. But it gives you a hint. It says that above the dam, the water is critical. And when it says frictionless flow, it means that you don't need to consider the head losses. From the point of view that I'm seeing this, it should be something like that. There is a dam here. The water is here, approaching the dam. And it says that here above the dam, you will experience YC, which is critical depth. Here you have Y1, which is 20 meter. It says that upstream of the dam, the depth is 20 meter. What else I have? I have the width of the channel. Here is a channel, which is 40 meter. Discharge 4,000 cubic meter per second. Normal depth, so I'm going to call it Y1, 20 meter. Encounter, the dam high is 4 meter. And it asks for YC because it says that above the dam we have YC. So basically it asks for critical depth. So first of all, what I'm doing, which is not necessary, but it should be double checked. I'm double checking to see if upstream, which is here, I have subcritical or supercritical. Because if I have subcritical, that's fine. Supercritical, it means that we will have problem because supercritical to critical happens by a hydraulic jump. So I'm going to start finding FR or fraud number 1. Do I have velocity? No. So I can find it by using that one. So finding that here gives me I think I have the fraud number, which is 0.36. That's less than 1, subcritical, and shows that you are fine to use the normal YC. Otherwise, if it was subcritical, it's going to pass the critical situation, hydraulic jump happens. So you need to do another approach. Now, I have the validation to find the critical depths. Critical depth has two equations, if you remember. One was for any kind of arbitrary cross section. The other one was just for the rectangular. So I'm going to use a rectangular because this cross section is rectangular. If you remember, the formula was Q2 over G, and that was YC. I don't have Q, but I can easily find that. How? Q over B is a small q, which is 4,000 over 40. The unit is cubic meter per second per unit of depth or width. So here, 9, which gives me this guy. So the water above the dam is around 10 meter. And as you can see, we didn't use the depth of the dam or the height of the dam. That was the information that we didn't use. So the red part is just to double check if the flow is subcritical, supercritical, or what. The solution is the blue part. I think probably if you write the two energy equation or Bernoulli for both 1 and 2, you will end up the correct solution and you can use 4 meter there. But since I'm going to use the critical depth formula, I prefer this one. Pretty sure if you use this two-side equation, 2-point equation for energy, you will get the correct answer. And that's the solution. Here it says that we should make sure that it's critical or not. Check that if it's subcritical, then start finding this guy. It used the main equation, but since I know that I have the easier version, I use the